somewhere in a quiet stretch of sky, in a direction most of us will never look toward. There is a galaxy so large that the entire Milky Way could fit inside it more than 50 times over. It does not appear bright in our skies. It does not have a familiar name. To the unaided eye, it is nothing at all, just a faint smudge of light in the constellation of Hydra, 2.5 billion light years away. But hidden inside that smudge is the largest single galaxy that has ever been measured, a slow glowing structure stretching across more than 5 million light years of space, with enough stars inside it to populate every galaxy you have ever heard of, and then several more besides. Its name is a C1101. Tonight, we are going to spend a long, calm evening in its company. We will travel slowly through what it is, where it lives, how it grew, what it teaches us, and what we still do not understand about objects on this scale. Settle in. We have a long journey ahead. Before we go any further, it helps to remember how big the night sky already feels from where we are sitting. On a clear evening, far from city light, you can stand in a field and look up at a band of soft milky brightness running overhead. That band is the inside of our own galaxy seen edge on, the Milky Way, a slowly turning disk of about 400 billion stars. From edge to edge, our galaxy measures roughly 100,000 light years across. Light, the fastest thing in the universe, takes 100,000 years to cross it. Within that disk live every star you have ever seen with your own eyes, every constellation, every familiar pattern in the sky. The sun, the earth, all of human history, all of human worry and love and noise and silence fits inside one small spiral arm of that disk, in a quiet neighborhood about 2/3 of the way out from the center. The Milky Way is not a small galaxy. It is, as galaxies go, a respectable, ordinary, full-sized spiral, a little larger than average, neither modest nor extraordinary. It is the kind of galaxy you would find in many places throughout the universe, doing what galaxies do, slowly turning in the dark, making and unmaking stars over billions of years. And yet, compared to IC 1101, our entire galaxy would be a single soft pebble next to a slow-moving mountain. To begin to feel that comparison, picture a coin held flat on the palm of your hand. Let that coin be the Milky Way. To represent IC 1101 at the same scale, you would need to set your coin down on a wide, smooth dinner plate and imagine a soft glow filling almost the entire surface, edge to edge. Our galaxy, on this scale, would be a small bright dot near the center, while the rest of the plate, all that surrounding light, all those countless stars, would belong to a single other galaxy. That is the kind of object we are talking about tonight. There is something worth pausing on, even before we go further. The fact that an object like this exists at all is, in a quiet way, surprising. For most of human history, no one suspected that anything beyond our own galaxy existed at all. The whole universe, as far as we knew, was the band of stars overhead and a handful of soft glowing patches that seemed to be inside it. The idea that there were other galaxies, other islands of stars far beyond our own, only entered serious astronomy in the early 20th century. The idea that some of those galaxies might be hundreds of times larger than our own had to wait even longer. And the idea that we could measure them, weigh them, count their stars, study their merger histories, all from a small wet planet around an ordinary star, would have seemed not so very long ago. like a kind of impossible reach. And yet here we are, on a quiet night, talking about exactly that. The history of how we even came to know IC 1101 begins not with a dramatic discovery, but with a slow, patient sweep of the sky. In the late 1700s, the astronomer William Herschel and his sister Caroline Herschel were carefully cataloging faint nebulae, soft patches of light that could be seen through their telescopes, but whose true nature was still entirely unknown. At that time, no one yet understood that some of these faint patches were galaxies in their own right, vast islands of stars far outside our own. They were simply called nebulae, from the Latin word for cloud. On a night in 1890, in another continent, the work of cataloging these soft glows was still continuing, and a Danish-Irish astronomer named John Louis Emile Dreyer was assembling all those entries into a master list known as the New General Catalogue, and later its supplements, the index catalogues. IC 1101 was the 1101st object listed in the second of those index catalogues in 1895. At the time, it was simply another small soft glow in a long list of soft glows. No one knew what it was. No one knew how far away it was. No one knew that, more than a century later, this faint smudge would still hold the title of one of the largest galaxies humanity has ever observed. It would take decades of work and the slow accumulation of better telescopes, better instruments, and better understanding before astronomers could even begin to take the measure of this object. The first real shift came in the early 20th century, when Edwin Hubble and others established that the soft glowing nebulae scattered across the sky were not nearby clouds within our own galaxy, but separate galaxies, each one its own enormous collection of stars, each one impossibly far away. With that single shift in understanding, the universe became immeasurably larger. The faint smudge in Hydra was no longer a small cloud. It was a galaxy, and a distant one, and an unusually bright one for its distance, which meant, by quiet implication, that it had to be very large indeed. That change in understanding deserves a moment of slow appreciation. For thousands of years of careful watching, generations of astronomers had stared at these patches of light without knowing what they were. Then, within the span of a few years, the picture shifted. The universe was no longer one galaxy with some clouds in it. It was many galaxies, many island universes, scattered across distances that no human had ever conceived of before. Every faint blur in the sky became a place. Every place became a story waiting to be told. And the patient work of telling those stories, galaxy by galaxy, has continued ever since. By the middle of the 20th century, astronomers had begun to recognize a particular kind of galaxy that lived in the centers of galaxy clusters. These galaxies were always elliptical in shape, smooth and rounded, and softly glowing rather than spiraled and structured. They were always very large, and they always sat at the gravitational heart of the cluster around them, surrounded by smaller galaxies that orbited them like moths around a quiet flame. Astronomers gave these objects a fitting name. They are called brightest cluster galaxies, sometimes shortened in scientific writing to BCGs, and within that family, a smaller subset are known as CD galaxies, a kind of supergiant elliptical with a faint, extended halo of stars stretching far out beyond their main body. IC 1101 is one of these. It is the brightest cluster galaxy at the center of a cluster known as Abell 2029, a structure containing thousands of galaxies, all bound together by their mutual gravity, all orbiting slowly around the center, where IC 1101 quietly sits. The cluster itself lies in the constellation of Hydra, the water serpent, the largest of the modern constellations by area. To find Hydra in the night sky, you would look toward the southern part of the sky on a spring evening in the northern hemisphere, where it stretches in a long winding line of faint stars. None of those visible stars have anything to do with IC 1101. They are all foreground stars, sitting comfortably within our own Milky Way, only a few hundred or a few thousand light years from us. The galaxy we are speaking of tonight lies far, far beyond them, more than 1 billion times farther than any star you have ever seen with the naked eye. Its light, when it reaches your telescope, has been traveling for over 1 billion years. The Earth, when that light first set out, was already old, but the human story had not yet begun. Single-celled life had been around for billions of years, but multicellular life was still in its early experimental phases. Mountains we know today had not yet formed. The configuration of the continents was different, and across all that time, as oceans rose and fell, as species came and went, as ice ages cycled and the planet turned, this light was traveling in a straight, quiet line toward a small blue world it had not yet learned the name of. The first thing to understand about IC 1101 is that it is not shaped like the galaxy we live in. Our Milky Way is a spiral galaxy, a flat rotating disk with arms wound outward from a central bulge, like the slow turning of a pinwheel. Spiral galaxies are full of dust, gas, and active star formation. New stars are being born in our galaxy tonight, glowing in the cold, dark clouds along the spiral arms. There is movement in a spiral galaxy in the obvious mechanical sense. You can see it. The arms turn, the clouds drift, the young hot stars trace bright patterns through the dust. IC 1101 is not like this. It is an elliptical galaxy, and a giant one. Elliptical galaxies are smooth, rounded, almost featureless to the eye. They have no spiral arms. They have very little gas and dust. They produce few new stars. Their light is dominated not by hot blue young stars, but by older, cooler, redder stars that have been quietly burning for many billions of years. If you could see IC 1101 with your own eyes from a few thousand light years away, it would not look like a beautiful pinwheel. It would look like a soft, golden, glowing cloud, gently denser at the center and gradually fading outward, with no clear edge, no visible structure, just a slow falling off of light into the surrounding dark. That softness is part of what makes it so difficult to measure. A spiral galaxy has a clear shape. You can see where the disk ends. With an elliptical galaxy, especially a supergiant elliptical with a faint extended halo, there is no obvious place where the galaxy stops and intergalactic space begins. The light just keeps going, fainter and fainter, until eventually it blends with the diffuse background of the cluster itself. So when astronomers say that IC 1101 stretches across more than 5 million light years, they are measuring out to a particular brightness threshold, a particular faint level of starlight, beyond which the galaxy is so dim it becomes hard to tell where its outer halo ends and the cluster's general glow begins. Different studies, using different methods and different thresholds, have produced different numbers. Some give a more conservative estimate of 2 million light years across. Others suggest something closer to 4. The often quoted figure of around 5.5 to 6 million light years comes from measurements of its very faint outer halo, the diffuse stellar light that extends far beyond the bright central body. What everyone agrees on is that this galaxy is, by any reasonable definition, enormous. It is one of the largest, possibly the largest, galaxy known. To put that in slow human terms, if you set out to cross it at the speed of light, the journey would take you several million years. By comparison, light crosses our own galaxy in 100,000 years. The number of stars inside IC 1101 has been estimated at around 100 trillion. Our Milky Way has about 400 billion. That puts IC 1101 at somewhere on the order of 250 times more stars than our entire galaxy. If you could somehow gather every star in the Milky Way into a single basket, and then go out and gather another and another and another, you would need over 200 such baskets to fill IC 1101. These numbers are the kind that resist being felt. The mind hears them, accepts them, and then quietly sets them aside. So let us slow down for a moment and try to feel them. Imagine that every star in the Milky Way was a single grain of sand, 400 billion grains. That alone is more sand than fits in any container you have ever held. It is more sand than fits in a bathtub, more than fits in a small swimming pool. To hold the Milky Way, in this picture, you would need a small dune, a calm rolling hill of fine pale sand, gently shifting in the wind. Now imagine, beside that dune, a wide, quiet beach stretching off into the distance. Not a little beach, but the kind of beach you might find on a long curving coast. The kind where you can walk for hours, and the shore still goes on, fading into the haze. A beach with enough sand, by some careful accounting, to hold 100 trillion grains. That beach is IC 1101. The Milky Way, the entirety of every star you have ever heard of, every star that has ever shone over any human eye, is one small dune at the edge of a long, slow, glowing shoreline. That is the galaxy we are spending the night with. There is another way to feel this, if the beach does not quite settle in. Imagine a single human life, a long, quiet life of about 80 years. In each one of those years, you would need to count 5 trillion stars, every year, without rest, to finish counting all the stars in IC 1101 by the time your life ended. Even at 1 star a second, working without ever stopping, the counting would take more than 3 million human lifetimes lined up end to end. The galaxy is not just larger than us in space. It is larger than us in any way we have of measuring largeness with our own slow, patient minds. Now, you may be wondering how a galaxy could possibly grow this large. To answer that, we need to take a slow step back and think for a while about how galaxies form and how they change over the long, quiet ages of the universe. In the very early universe, not long after the cosmos cooled enough for atoms to exist, matter was almost evenly distributed. Almost. There were small variations in density, tiny ripples left over from the earliest moments after the Big Bang, places where matter was very slightly more concentrated than average. Gravity, given time, has a particular gift. It takes small differences and quietly amplifies them. Over hundreds of millions of years, the slightly denser regions pulled in surrounding matter, growing denser still, while the slightly emptier regions grew emptier. Out of this slow, patient process, the first structures of the universe began to form. Dark matter, the unseen substance that makes up most of the matter in the cosmos, gathered into vast invisible scaffolds, into halos and filaments and sheets. Ordinary matter, drawn by the gravity of the dark matter, fell into these structures and began to glow. The first galaxies were small. They were not the grand spirals we see today. They were ragged, irregular, often violent things, full of bright young stars and dense gas clouds. They formed in the densest pockets of the early universe, and they did not stay alone for long. Because the universe is structured the way it is, with matter gathered into vast filaments and clusters, galaxies tend to form in groups. They orbit one another. They pull on one another. And over time, when their paths bring them too close, they merge. A galaxy merger is one of the slowest events in the universe. It does not happen in a flash. It does not happen in a year or in a million years. A typical major merger between two large galaxies takes 1 to 2 billion years to complete, from first approach to final settling. During that time, the two galaxies pass through one another, swing back, pass through again, and gradually lose their original structure. The stars themselves rarely collide. Stars are tiny compared to the empty space between them. And even when two galaxies pass through one another, almost every star simply drifts past every other star, untouched, unaware. What changes is the shape of the whole, the spiral arms, the rotating disks, the calm, orderly structure. All of these are gradually erased. What is left after the long, slow settling is a softer, rounder, more featureless object, an elliptical galaxy. This is how the largest galaxies in the universe are made. Not by growing slowly from the inside, but by feeding on their neighbors, slowly and gently, over billions of years. A brightest cluster galaxy like IC 1101 sits at the gravitational center of its cluster. And over the long ages, smaller galaxies that wander too close are pulled in, stretched, mingled, and finally absorbed. The supergiant elliptical we see today is, in a real sense, a record of every smaller galaxy that has ever fallen into it. Its stars are not all of the same age, or the same chemistry, or the same origin. Some of them formed in IC 1101 itself, long ago. Many of them formed elsewhere, in galaxies that no longer exist as separate objects. Galaxies that gave themselves up, billions of years ago, to the slow gravity of the central giant. This process is sometimes called galactic cannibalism, though that word, with its sharp edges, is not quite the right one for what is really happening. It is something gentler than that. It is more like the slow gathering of streams into a river, and rivers into a sea. The smaller galaxies were not destroyed in any violent sense. Their stars are still there. Their stars are still glowing tonight, somewhere inside the soft halo of IC 1101, mixed in with stars that were born under different skies in different galaxies long ago. If you could pick out a single star in the outer halo of this giant and trace its history backward, you might find that it was born in a galaxy that was already old when our solar system did not yet exist. That galaxy fell, slowly, toward the heart of the cluster, and over a billion-year embrace, it became part of something larger. The star kept shining. It still shines now. There is something quietly moving about this picture. A galaxy is not a single thing. It is the cumulative memory of every smaller thing that joined it. It is a strange comfort, in its own way, to think about that. Galaxies, the largest stable objects in the universe, are not built once and finished. They are built over and over, across billions of years, out of pieces that came from elsewhere. The shape we see today is only the latest version of the shape. 2 billion years ago, IC 1101 was a slightly different galaxy. 2 billion years from now, it will be a slightly different galaxy still. Nothing in the universe stays exactly the same. Even the giants are slowly changing, slowly gathering, slowly settling. Within IC 1101, at the very center, there is another structure worth thinking about for a while. Almost every large galaxy contains, at its core, a supermassive black hole. Our own Milky Way has one, a black hole called Sagittarius A star, with a mass of about 4 million suns. That sounds like a great deal, and it is, but on the scale of the universe, it is actually a relatively modest black hole. The galaxies at the centers of clusters, the brightest cluster galaxies, often contain black holes far more massive than this. Their hearts are heavier. Their gravity reaches further. The supermassive black hole at the center of IC 1101 is one of the most massive ever measured. Estimates place it somewhere between 40 and 100 billion solar masses. The exact number depends on which method you use and which assumptions you make. To give a sense of that, a black hole of 100 billion solar masses would be roughly 25,000 times more massive than the black hole at the center of our own galaxy. Its event horizon, the boundary inside which nothing can escape, would be larger than our entire solar system. Light, falling toward it, would take days simply to cross from one side of the horizon to the other. And yet, despite this almost incomprehensible mass, the black hole occupies only a tiny fraction of the total mass of IC 1101. Most of the galaxy's mass is in its stars, and in the dark matter halo that surrounds it, an unseen cloud of unknown particles whose gravity holds the whole structure together. The presence of such an enormous central black hole is not coincidental. Astronomers have known for decades that there is a strong relationship between the mass of a galaxy's central black hole and the mass of the galaxy itself. Bigger galaxies, on average, have bigger central black holes. The reasons for this are still being worked out, but it seems clear that galaxies and their central black holes grow together. They feed each other in a slow gravitational conversation that lasts for billions of years. When a galaxy merges with another, both the galaxies and their central black holes eventually combine. Two black holes, after a long, slow orbital dance, can spiral inward and become one. So the black hole at the heart of IC 1101 is, almost certainly, not a single primordial object. It is, like the galaxy around it, the merged remnant of many smaller black holes that came before. It is strange, in a quiet way, to think that the heart of the largest galaxy known is itself a record of long-completed mergers. Strange and beautiful. The black hole at its center is not just one thing. It is many things, joined together into one thing, holding the galaxy in place by its gravity, while the galaxy, in turn, holds the black hole in its center. If you wanted to picture, in slow human terms, the size of this central black hole, it might help to think about our own solar system as a reference. Our solar system, measured out to the orbit of Neptune, is about 9 billion kilometers across. The event horizon of a 100 billion solar mass black hole would be many times larger than that. You could fit our entire solar system, planets and all, comfortably inside, with room to spare. And from inside that horizon, no light, no signal, no message of any kind would ever come out. It is one of the deepest, simplest definitions of darkness in the universe. Not the darkness of empty space, where light merely has not yet arrived, but a darkness that holds light inside it, gently, and never lets it leave. Around the black hole, surrounding the galaxy as a whole, lies the cluster itself. Abel 2029 is its name, and it is a rich cluster, meaning that it contains a great many galaxies, perhaps several thousand, all bound together gravitationally. These galaxies move in slow orbits around the cluster's center of mass, taking billions of years to complete a single loop. Between the galaxies, filling the space within the cluster, there is something else, often forgotten in popular descriptions of galaxies. It is a vast cloud of extremely thin, extremely hot gas, called the intracluster medium. This gas is so thin that by the standards of any laboratory we could ever build, it would be considered a near-perfect vacuum. But it fills such an enormous volume and is so hot that it actually contains more total mass than all the visible stars in all the galaxies in the cluster combined. It glows in the X-ray part of the electromagnetic spectrum, invisible to the human eye, but bright and clear to the X-ray observatories we have placed in orbit above the Earth. When astronomers turn an X-ray telescope toward Abel 2029, they see a soft, glowing pool of light centered on IC 1101. The cluster's gas, heated to tens of millions of degrees by the gravitational compression of the cluster itself, gives off a quiet, steady glow. And inside that glow, near the center, certain features begin to emerge. There are slight asymmetries in the temperature and density of the gas, signs of past disturbances, hints that other clusters or large groups of galaxies may have passed through the region, leaving behind subtle ripples in the hot gas. Some studies have found cold fronts, sharp edges in the gas where slightly cooler material meets slightly hotter material, traveling slowly through the cluster like the wakes of distant ships. There is no sound out there, of course. Sound needs a medium dense enough to carry it, and the cluster gas is too thin for ordinary sound. But if you could listen with the right instruments, in the deep, low frequencies that cluster gas can support, the disturbances around IC 1101 would be a kind of quiet, almost inaudible hum, a slow pressure wave moving through the dark. It is worth noting, for a moment, that this hot intracluster gas was discovered relatively recently in the long story of astronomy. Until X-ray observatories were placed in orbit, beginning in the 1960s and 70s, no one knew that clusters of galaxies were filled with this hot, glowing material. The gas had always been there. It had always been gently glowing in X-rays. But human eyes could not see it, and Earth's atmosphere blocks most X-rays from reaching the ground. So we had no way of detecting it until we built telescopes that could float above the atmosphere. Once those telescopes opened their eyes, the universe quietly revealed another layer of itself. The clusters of galaxies were not just collections of galaxies. They were also vast pools of warm, thin gas, bigger than the galaxies themselves, holding everything together in a softly glowing bath. There is something gentle about that. The universe had always been showing us this, and we had simply not had the eyes for it yet. Now, having walked together through what IC 1101 is, where it lives, and how it likely grew, it is worth pausing on a question that may have already begun to settle in the back of your mind. Is IC 1101 truly the biggest galaxy in the universe? Or is it simply the biggest one we have measured so far? This is one of the gentler mysteries in this story. The honest answer is that we do not know. For a long time, IC 1101 has held the popular title of largest known galaxy. In many textbooks, in many documentaries, it is named as the record holder. But the more astronomers study supergiant elliptical galaxies in the centers of clusters, the more they realize that defining the size of such a galaxy is, in some ways, an artistic decision as much as a scientific one. The faint outer halos of these galaxies blend into the diffuse light of their clusters. There is no clean boundary. Different choices about where to draw the edge produce different size estimates. Some careful recent studies have suggested that, with stricter definitions of where a galaxy ends, IC 1101's main body may be more comparable in size to other supergiant ellipticals, and that some of the most extreme estimates of its diameter come from measuring its very faintest extended light. There are also other contenders. Galaxies like ESO 306-17, another giant elliptical in another cluster, have been suggested as similarly enormous. There are the so-called fossil group central galaxies, single huge ellipticals that sit alone in groups where all the smaller galaxies have already merged into them. Some of these are also extremely large. And in the deep universe, in clusters we have only begun to study with the latest telescopes, there may well be even larger objects waiting quietly to be measured. So the precise crown of largest galaxy in the universe may shift as our methods sharpen. What is not in doubt is that IC 1101 belongs to the rare and quiet club of objects that approach the upper limits of how big a single galaxy can become. Whether it is the very largest or simply among the very largest, it is a member of a small family of cosmic giants, and its story is the story of how such giants come to be at all. There is, in fact, a theoretical question buried in this. Is there a maximum size that a galaxy can reach? In principle, galaxies could keep growing as long as they keep merging with other galaxies. But in practice, the ability of a galaxy to grow depends on what is around it. A galaxy in the center of a cluster has plenty of food, so to speak. Smaller galaxies are constantly being fed into it by the gravity of the cluster. But even this process slows down over time. As the cluster's central galaxy consumes more and more of its neighbors, the supply of mergeable galaxies in the immediate region begins to dwindle. Eventually, there is simply less left to absorb. Combined with the overall expansion of the universe, which is gradually pulling the largest scale structures apart, this means that there is, in practice, an upper limit to how massive a single galaxy can become in the available age of the cosmos. We do not know exactly what that limit is, but it appears that the brightest clustered galaxies of the present universe, including IC 1101, are getting close to it. In other words, it is possible that we are looking, when we look at IC 1101, at something near the edge of what is even possible. Not a galaxy that just happens to be very large, but a galaxy near the natural ceiling of galactic growth, set by physics and time and the slow expansion of space. Let us take a long, quiet moment to sit with that. Sometimes it is worth stepping out of the numbers and trying instead to imagine what it would be like to be inside a place like this. Suppose, for the sake of slow imagination, that there is a planet somewhere within IC 1101, orbiting a small, calm, sun-like star. The star is somewhere in the middle reaches of the galaxy, neither at the bright, crowded center, nor far out in the dim halo. From this planet, what would the night sky look like? The first thing you might notice is that the stars overhead seem strangely uniform in color. In our skies, we see a mix of blue and white and yellow and orange and red stars, each color a hint of a different mass and stage of life. In our skies, blue stars are common because new stars are still being born around us, and the youngest, hottest, bluest ones live brightly for a while before they die. But in an old elliptical galaxy, like IC 1101, almost all the brightest stars finished forming a very long time ago. The blue stars are mostly gone. What remains are the older yellow and orange and red stars, the slow, steady burners that live for many billions of years. The night sky from a planet in IC 1101 would have a softer, warmer color overall. A sky leaning toward gold and amber and quiet rose, rather than the cool blue-white we sometimes see in the brightest stars of the Milky Way. You would also see, in many directions, faint diffuse glows where smaller galaxies have been digested over the eons. Streams of stars, called stellar streams, often remain after a smaller galaxy has been pulled apart by the gravity of the larger one. These streams loop and arc through the halo, faint enough that you would only see them under a very dark sky, but real, present, woven through the structure of the galaxy you live in. You would be living, in a sense, inside the slow memory of every smaller galaxy that came before. If you turned your gaze toward the center of the galaxy, you would see a soft, golden, intensely bright glow, a dense crowding of older stars packed into the central regions. There would be no spiral arms, no familiar Milky Way band stretching across the heavens. Instead, you might see a wide, soft brightness, almost like a luminous fog, with the densest part of it pulling your eye toward the heart of the galaxy. Somewhere within that fog, hidden behind the crowded light, lies the supermassive black hole, calmly gathering. From your planet, on a calm night, with the right kind of telescope, you could perhaps trace the gentle motion of certain bright stars near that center, watching them swing slowly through their orbits around the dark heart of everything. And if you turned in the other direction, away from the center, and looked outward, the night sky would gradually thin, the stars becoming sparser, the blackness between them deepening. Eventually, beyond your galaxy, in the deep reaches of the cluster, you would catch glimpses of other galaxies, smaller ellipticals, scattered like soft glowing seeds in the dark. And beyond those, faintly, at a great distance, perhaps the soft suggestion of other clusters in the larger structure of the cosmos, though most of that would be too far and too faint to see with eyes alone. This is what it is like, at least in slow imagination, to live inside something this large, not loud, not threatening, just very, very full of light, in patterns we are still learning to read. There is one more detail worth dwelling on in this imagined view. The night on such a planet would be a longer experience than it is for us. Surrounded by so many distant stars, with so much soft glow in every direction, the sky would never be as dark as the darkest skies on Earth. There would always be a kind of low ambient light from the galaxy itself. Not bright enough to read by, not bright enough to wash out the brighter stars, just enough to soften the darkness, to give the night a gentle background warmth. It is a kind of darkness humans have not really experienced, a darkness with company, a night that is never entirely empty. Coming back now, from that imagined planet to our own quiet world, it is worth thinking for a while about how we even know any of this from where we sit. Almost everything we know about AC 1101 comes from light. The galaxy is too far away to send any spacecraft to. It is far beyond the reach of any current or planned mission. We will never visit it. We will never image its individual stars in the way that we image individual stars in our own galaxy. Everything we know about it has been gathered by patiently catching the light it has sent us and decoding what that light has to say. Light, as it travels across the universe, carries an enormous amount of information, far more than the human eye can perceive. It carries information about the chemistry of the gas it passed through, the temperature of the matter that emitted it, the speed at which that matter was moving, the gravitational field it climbed out of. Astronomers, with their telescopes and their spectrographs, have learned to read these patterns the way a careful reader learns to read a text in another language. From the light of IC 1101, they have measured the rotation of the galaxy, the average ages of its stars, the chemistry of its outer halo, the hot gas surrounding it. From that same light, red-shifted by the long expansion of space, they can determine its distance and its motion through the cluster. This is, in its own quiet way, an extraordinary thing. We, on a small wet world near the outer edge of an ordinary spiral galaxy, can stare up at the sky for long enough, with the right instruments, and slowly piece together the inner life of a galaxy 2.5 billion light-years away. We can describe its shape, its mass, its history, the slow merging of its parts. We can do this without ever leaving home. We can do this while, across most of the planet, the lights are on, and the conversations are happening, and people are getting on with their everyday lives, mostly unaware that, on certain dark mountaintops and in certain orbiting telescopes, the slow, patient work of mapping IC 1101 is quietly continuing. The instruments that have contributed to this mapping include some of the great telescopes of the past century. The Hubble Space Telescope has imaged Able 2029 in detail, allowing astronomers to study the inner structure of IC 1101 and the smaller galaxies around it. X-ray observatories like Chandra and XMM Newton have studied the hot intracluster gas. Ground-based telescopes have measured the dynamics of the galaxy and its neighbors. More recently, the James Webb Space Telescope, with its ability to peer into infrared light, has begun to look more deeply at the centers of clusters and at the faint outer halos of supergiant ellipticals, refining our picture of how these objects have grown across cosmic time. Each instrument adds a new layer of detail, like successive readings of the same long, slow text, revealing more meaning every time. Behind every one of those instruments, of course, are the people. There is a quiet human story woven through all of this work. Every observation of IC 1101 was made by someone, or by a team of someones, sitting at a console at 3 in the morning, or running calculations on a computer, or arguing politely with a colleague about how to interpret a faint pattern in the data. The galaxy itself does not know we are watching. It does not care. It would continue to glow exactly the same whether anyone on Earth had ever looked at it or not. But the looking itself, the patient gathering of one photon after another, the slow building of understanding from one paper to the next, is a deeply human activity. It is a kind of long, quiet conversation that humanity is having with the universe, a conversation in which most of the speaking is done by light, and most of the listening is done by careful, patient people who have devoted their working lives to hearing what is there. There are still many things we do not know. Some of them are practical, the kind of details that future telescopes will eventually fill in. Others are deeper, the kind of questions that may take generations to answer. We do not know, for example, the exact mass of the central black hole. We do not know, in detail, the merger history of the galaxy. We do not know exactly how many smaller galaxies it has consumed, or when, or in what order. We do not know precisely how its dark matter halo is shaped, though we know it must be enormous. We do not know how the galaxy will continue to evolve over the next billions of years. Will it keep growing, gathering in more of its neighbors, becoming heavier still? Will the slow cosmic expansion eventually starve it, leaving it as a quiet, isolated giant? The cluster around it is bound by its own gravity, so it will not be torn apart by the universe's expansion. But the rate at which new mergers occur within the cluster is expected to slow as the available material is used up. So there is a real sense in which IC 1101, large as it is, may be approaching its final form. The galaxy of the very far future may not be much larger than the one we see today. It may simply settle more and more into a long, calm, ageless stillness. That is, in itself, a strange thought. The universe is, in some sense, still very young in the lives of objects like this. Galaxies have only had 13.5 billion years to grow. That sounds like a long time, and on human scales, it is unimaginably long. But if galaxies last for many tens of billions of years, then we are watching IC 1101 in something like a middle age. There will be many billions of years more during which this galaxy continues to exist, slowly cooling, slowly losing the last of its star formation, slowly settling into an even quieter, even older version of itself. By the time the universe is several times its current age, the supergiant elliptical galaxies will be mostly populated by old red stars, their cores burning slowly, the youngest of them already several billion years old. New star formation, long since slowed, will eventually cease. The galaxies will not vanish. They will simply grow steadily fainter and steadily redder and steadily older. The light from IC 1101 100 billion years from now, if anyone is looking, will be a deeper red than it is today, a softer glow, a quieter warmth, the long late afternoon of a galaxy. There is a particular kind of peace in that thought. Let us turn our attention, for a while, away from IC 1101 itself, and toward the larger structure it belongs to. Galaxies, even the largest of them, do not exist in isolation. They are part of a vast pattern that fills the universe, a pattern that astronomers call the cosmic web. When we map the positions of galaxies on the largest scales, the picture that emerges is not random. It is not a uniform sprinkle of points across space. It is a network. Galaxies gather along long, thin filaments, like threads. Where filaments meet, they form clusters, dense knots of galaxies bound by their mutual gravity. Where filaments are sparse, vast empty regions stretch across the universe, called voids, regions sometimes hundreds of millions of light years across, with very few galaxies inside them. The whole structure resembles something like a soft, three-dimensional web drawn through the universe, its threads glowing where galaxies have gathered, its open spaces dark and quiet. IC 1101 sits at one of the brightest knots of this web. Its cluster, Able 2029, is a dense gathering of thousands of galaxies, a node where many filaments converge. The cluster is itself part of a larger structure, a supercluster, in which it is connected to other clusters by long, thin streams of galaxies and gas and dark matter. From a great enough distance, the entire cosmic web would look something like a faint pattern of lace stretched across the dark, with our own Milky Way one small bright dot among uncountable others. This is one of the deepest pictures modern cosmology has given us. It tells us that the universe, on the largest scales, is not empty, but it is also not full. It has a structure. It has geography. There are roads and there are wildernesses. There are crowded cities and there are deep silences. IC 1101 is in one of the great cities, surrounded by countless others. Our own galaxy, by contrast, is in a much quieter neighborhood, part of a small cluster called the local group, which contains only a few dozen galaxies, with the Milky Way and the Andromeda Galaxy as the two largest members. In several billion years, the Milky Way and Andromeda will themselves merge, slowly, over hundreds of millions of years, eventually forming a single new elliptical galaxy that astronomers sometimes informally call Milkomeda. That galaxy will be larger than either of its parents, but it will not approach the size of IC 1101. It will be a respectable elliptical, perhaps similar in size to many of the brighter ellipticals in nearby clusters, but it will not be a giant. The local group simply does not contain enough material for that. Our galaxy will become old and quiet and red, but it will never become a galaxy on the scale of the one we are visiting tonight. Ours, in other words, is a smaller story, a quieter house in a quieter part of the world. There is something almost reassuring about that when you sit with it for a moment. We do not live at the center of the largest cluster in the universe. We do not live inside the most massive galaxy. We live in a peaceful suburb of the cosmos, in a small group of friendly galaxies, in an unremarkable spiral, around an ordinary star. From that quiet place, we can look outward and see the bright cities, the great clusters, the supergiants. We do not have to live inside them to know they are there. The universe has many kinds of places, and ours is one of the calmer ones. That, in itself, may be a small piece of the reason we are here, listening, instead of being torn through space by the gravity of some far more dramatic environment. Coming back to a CC 1101, there is one more thing worth dwelling on for a while. We have spoken about the galaxy's size, its history, its black hole, its place in the cosmic web. But we have not spent much time thinking about what it means that we know about this object at all. 2.5 billion years ago, a long, slow process took place at the center of a distant cluster. Stars in that galaxy were quietly burning, as they had been for many billions of years. Some of those stars were releasing photons, particles of light, in random directions. A small fraction of those photons happened to be moving in a direction that would eventually intersect, after an immensely long journey, with a small blue planet in another galaxy. That planet did not yet have humans on it. It did not yet have any of the species you would recognize. And yet that light, those photons, kept moving, calmly, steadily, through the dark. For 2.5 billion years, those photons traveled. Across that span, on Earth, single-celled life slowly diversified. Cells learned to combine into colonies. Colonies became simple multicellular organisms. The Cambrian explosion, with its strange, beautiful sea creatures, came and went. Fish appeared. Plants colonized the land. Insects, then amphibians, then reptiles, then mammals, then birds. Continents drifted into new shapes. Mountain ranges rose and were worn down. Asteroids arrived and altered the course of life. Mass extinctions came and went. Eventually, on one branch of the tree of life, primates appeared. Eventually, one kind of primate stood up, looked at the sky, and began to wonder. And eventually, after many further years, after many further generations, and many further wonderings, a small subset of that species built telescopes. They pointed those telescopes at certain quiet patches of sky. And those photons, those particular photons that had set out from IC 1101 2.5 billion years before, finally arrived. They fell into a mirror. They were focused into a detector. They became data, which became maps, which became understanding. We, on this small world, are the first creatures we know of who have caught those photons and made sense of them. Across all of cosmic time, across the long, quiet history of the universe, what we are doing here, looking outward and asking what we see, is something that is rare, perhaps very rare. It may be that other minds in other galaxies are doing the same thing tonight. We do not know. The universe has been mostly silent on that question. But what we do know is that here, in this small corner of one ordinary spiral, a few of us have learned to look up at a faint smudge in the constellation of Hydra, and slowly, patiently, with the care of careful readers, work out that we are looking at an object more than 5 million light-years across, made of 100 trillion stars, 2.5 billion light-years away. That, in its own quiet way, is also an extraordinary thing. Think, for a moment, about the chain of small events that had to happen for any of this to be known. A particular star in IC 1101 had to form, billions of years ago, in a particular place in the galaxy. It had to live long enough to be shining at the right moment, 2.5 billion years ago, when its light could reach us today. The photons it released had to travel along an unobstructed path through the cluster, through the intergalactic medium, through the long stretches of nearly empty space. They had to enter the Milky Way without being absorbed by interstellar dust. They had to pass through the outer regions of our own galaxy, then the inner regions, then the local neighborhood of our solar system, then the orbit of the outer planets, then the orbit of Earth. They had to fall, finally, on a telescope in just the right moment, when that telescope happened to be pointed in just the right direction. Each link in that chain seems unlikely on its own. The whole chain together seems vanishingly small. And yet it happened, and it keeps happening, every clear night, on every working telescope, on every dark mountain on Earth. Light from impossibly far places is arriving, exactly when we are ready to receive it. We are very small. The galaxy we live in is one of countless galaxies. The galaxy we have been thinking about tonight is itself only one of countless giant ellipticals scattered across the universe. The numbers extend in every direction, beyond our ability to feel them. And yet, somewhere in the middle of all of that, there is also you. There is a body in a bed, breathing slowly, listening to a voice describe a galaxy in a constellation you cannot see from where you are. There is a small warm room around you. There is a planet beneath you, turning quietly on its axis, carrying you, along with everyone else, through the long arc of an ordinary night. The light from IC 1101 is, even now, still arriving. Telescopes are still catching it. Astronomers, in some quiet observatory somewhere in the world, are still making measurements. Tomorrow, there will be a little more data than there was today. The picture will become a little sharper. The mass of the central black hole will be a little better constrained. The shape of the outer halo will be a little better mapped. And the galaxy, 2.5 billion years away, will continue doing exactly what it has been doing for as long as it has existed. It will continue to turn very slowly. It will continue to glow very softly. It will continue to gather very gently the wandering light of every smaller world that drifts too close. There is, in the end, something almost domestic about a galaxy like this. For all its scale, for all its strangeness, for all the numbers that resist being felt, IC1101 is a quiet object. It is not exploding. It is not collapsing. It is not racing toward any kind of climax. It is doing what it has done for billions of years, which is to glow softly, hold its stars in place, and slowly absorb whatever wanders in. There is no drama at the heart of it. There is only a long, slow keeping. The universe does not seem to be in a hurry. It has all the time in the world, and more. Stars are forming tonight that will outlast every memory of every human who has ever lived. Galaxies are merging tonight in slow embraces that will not finish for billions of years. And IC1101, the giant in Hydra, sits quietly at the center of its cluster, doing what it has done for ages, content with its own slow keeping of time. You are allowed to be small inside that. You are allowed to set down the long list of things you were holding before this video began. The universe will go on. The galaxies will keep turning. Whatever it is you were trying to solve in your head a few hours ago, whatever was waiting for you tomorrow, none of it has gone anywhere. But none of it is needed in this room right now either. There is only the slow voice and the dark behind your eyelids. And somewhere far above, 2.5 billion light years away, a soft golden cloud of 100 trillion stars, still glowing, still gathering, still here. Sleep deeply. The universe will still be here when you wake.